Now I'm. Yeah, thank you. So, yes. Yeah. Yeah, that's okay. Yeah. Let me just show how to edit this path string. If you go for environment variables for your account, then there are both local for the account and for the system, but we can go for path and edit that one. Then there is all of this that is printed here on the screen behind. They come from these different, and I think I did put in user Lyric bin at the top here because I want programs to be present there to be found first. Normally, in Foolproof Suite, for example, that is in the far end here. So if I add something else, I should add C colon bin 2, for example. That is also a folder that is present in my directory. But first it will look here, and then in the Windows system directory, and then in Windows, etc. And this will be the last folder search. Click on OK and OK, and then I think the new path is probably not present. We need to exit this command line and restart it. If you don't have an icon, you can type CMD. And you will have a black screen. That is the default path. There should be a bin 2, yes, in the end of it. So, well, then in this bin directory, you put all. This is very small character. You put all your programs that you would like to have accessible, for example, 3 or 90.exe or something like that. Shell that you can't live without. And then going to somewhere where we have the data, we go to. I go to my Dropbox, but you maybe we shouldn't do it like that. We should do it so that you could follow. Exercises, exercise 4. Let's download, for example, these 2 files. Or they are in Box now, but it's difficult to operate with the command line in Box, actually. So it's better if you copy the files. At least I have the experience that it's easier to copy them. I copy, and then where should we go? To somewhere on this PC, on D maybe. Here we make a directory. Kush, we can call it. And then I have the data just at the local directory. Maybe it works with connecting to Box directory, but I'm not sure. So we go back from here. See, the CD is changed directory. So I made CD dot dot, that means go to parent directory. Now we should go down to kurs. So, and let's see. Yeah, there are these two files. So, what kind of editing program are you using? Notepad, is that a possibility? That's quite acceptable. Let's see if we can. So these are now a typical Treor input file is just a text line, anything for remembering. And either you create it via some external software or you edit it like here. And then on each line, there should be a spacing value. And this spacing could be either to theta. I can type that on. At least. By choice keyword field and choice 3 or 4. I think theta or d values are definitely the most usual spacing method. If you want to check whether choice equals 3 is the correct value, there is only one way to do it, and that is going to manual. It is available in programs and Treor. There it is. I did put up some different versions of Treor, and I think I recommend the oldest one, Treor 90. 97 is approximately the same. Treor 10 implies some possibility to make a correction for 0-point error, but I had some problem with Treor 10. It sometimes crashes, and I think Treor 90 will solve most of our problems. So for your case, I would say that take these executable 90, 97, and 10 and put them in the bin directory that you created. Also, perhaps the manual, you need to remember where to have it. The Treor manual is quite old. You see it's actually written in a form of a comment list in the programming language Fortran. With a C on as the first character. But you can, for example, search for choice equals 4 if d values, but we want the next one. Next. Here they are. Choice. There is so. Where is here? It says in the list of keywords down here. 0 means sine squared theta. This is the default if you don't give any choice parameter. 1, 2, 3. 3 is 2 theta, and 4 is d values. This is very old-fashioned way of giving keywords, but yeah, still it works. So Notepad we had, here is Notepad, yes. The data should be finished by a blank line. If we, for example, would like to save these data for later use, then we could put them after. We need the data and a blank line. Now we had 2 blank line, that is also okay. And then some keywords. And the last keyword should be N star. The only problem with N star is that it must not, the star must not be the final character in the file. So you need at least a line feed or something like that after it. But otherwise, all the keywords are something like a word equals some value and then a comma. We don't use decimal comma, we use decimal point. Since this comes, the origin of this program is from the 1960s. And at that time we still had comma maybe, but everything in computer business was American oriented, so, and they have decimal point. Wave equal 1.5406 is actually the standard wavelength, so it doesn't need to be input, but it doesn't hurt either. And especially if you're using some non-standard radiation from synchrotrons, you need to put in the wavelengths, at least if you have 2 theta values. Otherwise, you will get a quite a reasonable unit cell, but it will be wrong by a factor related to the wavelengths. And then how should TREOR actually process these data? Well, we want TREOR to, if we don't have this volume equals a negative value, then it will only test cubic, tetragonal, hexagonal, and orthorhombic, and then it will stop because most of this, those were the simple tests. Monoclinic and triclinic is difficult. But with the indication that volume is a negative value, actually the negative sign here is a shorthand of indicating, instructing TREOR to test all different symmetries. If it finds a solution, then it stops. But if not, then it will continue and also start with the triclinic version, which will take some time, but I mean, only a matter of minutes or so. Minus 2000, the value is a limit, so to say, not to exceed, not at least a lot. So it won't continue to search for unit cells and high index combinations that would be much bigger than 2000 cubic angstrom. We can see, we put these index back. And the actual format, I think, doesn't matter where the values are, but they should be in the beginning of the line, at least. And 1 value per line. So, yes. Okay. Yeah. Yeah. If you do this notepad. Do you have the file in your? Yeah. Yeah, there are some problems working with command line. As soon as spoiled with you get rid of this graphical user interface idea. This is also graphical. So if you're going to use 3090, I recommend using extension .tre because it will ask only for the name. So now I suppose my computer knows where Prior is available. It's available in the bin directory. And it says enter product name, no extension. And that's a reason why you should use TRE. If you use, for example, 397, I think it will ask for input file, and then you need to give the full name, like agcl.tre. Now I'm using 97, but it's otherwise very similar to 390. So output file, what should we call it? agcl.out, maybe? And by some reason, one of the authors to this program, he wanted to have several different type of output files with a condensed output also, but we can call it C, DC maybe? No, 390 is simpler, AGCL. Yeah. Oh, yeah. We'll see. From, yeah, if you can, okay, see. Thank you. Star. Yeah. And the star. So obviously I love three. Mm. Have a bin, you create a bin director. May I? One of these, are they or yeah, yeah. But So that is big. Refused.
Yeah. Finance.
Great.
No.
Yes, then have talk or not the box. Yeah.
Yeah. Okay. Yeah.
Yeah, but yeah, okay. You have downloaded and then we continue. So the result here was you got an interesting result. So what 390 creates a file .lst, and we can look at that one with, for example, Notepad ogtl.lst. First is just a echo of the input file and some information how it will perform the different tests. It makes a cubic test with and select the two different baselines as number 1 and number 2, and it also selects maximum HKL values of 444 and the maximum sum of 6 that delimits the number of possible values for the first line. It makes some cubic test, but obviously don't succeed. So it goes further to some tetragonal test, selects 3 sets of baselines, either 1 and 2 or 1 and 3 or 2 and 3. That could be affected by different keywords in the input file if you want to extend it, if you really suspect that this is it would be fun if it would be tetragonal. And here is actually a tetragonal possible solution. Total number of lines is 17, but A and B was 3.92 and 5.54 with a unit cell volume of 85 only. This is quite fair. Everything is okay until we come to the end here. And then we see that 3 of the lines do not have any HKL values. And if these 3 lines are, if we shouldn't expect them to be impurities or anything else, they need to be indexed also. 17 out of 20 lines were indexed, yes, but it's not enough. Notepad, and I can do it again. This is LST. Yeah. So looking at that file. Another thing is that that is not at all very important. Some lines has an observed line, but one observed and one calculated line. That's quite okay. And delta in this case in sine squared theta, but the observed to theta was 27.87 and it calculated with 27.84. So it's a difference of, say, something like 0.03. It's not optimal, but maybe acceptable. Some lines some observed lines are accompanied by another 2D index combination. 110 and 002 obviously come at the same position approximately. The calculated positions over here, 32.230 and 32.292, they are both I think within 0.1 degree of the observed line, and then they are listed, both of them. And this so-called error window is adjustable. You can set it also as with some keyword. But this is nothing wrong in a way. It's just that to inform you that there is a 110 reflection close to, but 002 is closest. But actually, since there are 3 unindexed lines here in the bottom, there are strong, well, it's definitely wrong if it's single phase. If these 3 are not impurities, then we don't have any, we can't explain, we can't use this unit cell, even though the figure merits here are 62, the Wolf figure merit, which is very, very large and quite good. So this tetragonal unit set fits the first 17 lines very well, but it's you don't accept the 3 unindexed lines. It looks here, it also prints out that 3 lines are unindexed. this Smith and Schneider is also very good. 17 is quite acceptable. 72 here is the calculated number of lines up to line number 17. And 72 lines up to observed line number 17 is perhaps something to be suspicious towards. Why would say something like 55 lines be unobserved? They could be very weak, yes, but so let's continue maybe. This is 2 unobserved lines. This is not so bad, but still bad. 3 unobserved lines. 1 unobserved. This may be the solution, Treor says, because 1 line is at least less serious than 3 lines. But it's still wrong. At least 1 is 1 too much. And then what does it do afterwards? Does it continue? You could sometimes get a very long list here. This may be the solution once more. No, now it gives up. Then I suggest to let's see, Alt F(x). We should. Was it so difficult? This sorry. Alt F, open och nej, redo that. Cancel. So I suggest to put in a keyword called merit. And maybe we should, what was the highest merit? It was something like 67, we say 70. So then it will not give up until it finds a solution with the merit of 70 or not. And then save this input file, exit and rerun Treor 90 och CL. What was this? AGCL dot. Very short. Error, program control card. Did we do something wrong? What is wrong by merit? Could be that it's not capital letters. Nej, I can't save the file. AGL. Now it works at least. In the box in program 3, or there should be.
There's for your mind.
Yeah. Yes. Yes. It should be the same, but.
Yes, I from the.
Um, so. Download.
Sorry, like on the computer of the
Okay. Now let's.
Hello.
Um,
I have one. Yeah. One. Now it's done. Now I'll close it. What is the video? This. I just. Okay, yeah. Microphone. I know. What? That's so weird. Yeah. Sorry. This is like the high score yesterday. We were like, well, sorry, kind of. I just. I. Oh.
Yeah.
This is like that.
Yeah, but and then copy them. Yeah. Then. Oh. And then. Or. I want to. Okay. Oh. Okay.
I
Yeah. Okay. So,
I
okay. Then, okay. Okay. Yeah, but it's still wrong. It works, but so what is wrong? Do we believe? Yeah, we don't need to believe it since it is unindexed lines. So what could be wrong? Do we have even? Yeah, we did. By the way, I changed this merit to 70 here. Maybe we should have a look at what was the result of that. I think that a lot more output was produced. We could perhaps search for merit. Find cannot find merit. Search for unindexed. 3 lines, that is too much. 3, 2, 2, 3, 2, 2, 1. That is better than 2 and 3. Why not? I want 0. I have no 0. So it could be because we have too inaccurate data. I try to. So perhaps we should tell Treo that we have less accurate data than necessary. And there is a keyword called D1. The default value is 0.0002, but we can increase that to 0003 maybe. And there is a keyword called D2, which the default value is 0.0004, but we can increase that to slightly more. Let's say that these two values, they are slightly more than default values. Yes, 3 zeros. If you take 2 zeros, it also works, but then it will then it's 10 times worse. So it will. The D1 and D2 are the maximum allowed difference between a calculated sine square theta and an observed sine square theta. Deviation, yes. So the bigger they are, the less accurate are your peak positions. You could go to maybe a unit in the third decimal, but going bigger is perhaps a problem. But well, why not? If you have the data, if this is your only data set, then and we need to find the unit cell, and we are convinced that it is single phase, 3 or 90. Still, what is problem? I don't think we found, since it ran all the way to triclinic. I don't think we go for a huge, say, one in. This is really huge. Yeah, that's true. The D1 goes for lines that are in the beginning with the sine square theta less than 0.05. This is approximately 20 degrees. Now we got another cubic test, and here we got an interesting result. I mean, maybe we don't trust Treo anymore, but and you shouldn't. Never trust a computer. Test 5.55. This is really a nice, good-looking indexing of a cubic pattern. Perhaps if we do suspect that this is cubic, maybe we should have actually looked at it with manual methods, paper and pencil, because that could be done. 0 lines are unindexed, and figure merit is 79. M15, 15 because there are only 15 lines. Yes.
And then married. And so like this one. Annually. And. I. Yeah. Yeah. Yeah, he added them. Yeah, so basically value how much value vary. So the value are
Okay, and then give AGCL. Sorry. This is so and make a guitar for then on the I think it is out. No, you should just stop this. If you change the if you go in load the AGCL.pre into Notepad. Azure.
No. Okay. Yeah. Then.
So if you type in that line also. In the .tre file, make no.
Then, yeah. The whole
Stop,
thing.
quit it. Then notepad agcl.tre. That agcl, not the .out, but the tre. And then yeah. Comma, yeah, that could can delete that one. Merit. And a comma after 0.002. Comma. Dissident. The author of 3 or rang me. Comma. Come on. Now it's here. Save this. And then run again. Yeah. With that one and
That one.
yeah. And AGCL. AG.TRE. Hmm. Let me see this file again. See the AGCL. Oh, but here you didn't save it. D1, yes. And then comma D2 equals 2 and comma. And then save this one. Don't forget to save it. You need to save it. File, save, Control S, yes. And then exit. And rerun AGCL.TRE. There you have the solution. Why do you think we had so much problem with the simple cubic pattern? Yeah, and silver chloride is I did a precipitate and I filter off only a little bit. So I put it on, I kept it actually on the filter paper and put the filter paper on the wafer. So I had a quite large systematic error. It's bad data. It would have been better. I haven't done that yet, but I will do that before I die. to synthesize a lot of silver chloride and record it in backloaded, because then the systematic errors would be more or less absent. We don't have any good way to actually deal with the systematic errors in your 90 version. But we can see how does it work with the not the foolproof. What is the other program? There are so many programs. What's it called? HiScore. There is a 390 version in HiScore. So we can open and where are our files? We need to remember where we did download them. I did create a directory called Kush, and here they are. This XRDML is the out file from the differential. And yeah, here it is. This looks perhaps like an excellent pattern. It's let us go into treatment. High score requires us to determine a background, otherwise it can't. Nej, men... Hallå Per-Erik, jag har lektion. Hallå, jag har lektion. Kan jag ringa upp dig senare? Ja, det kan jag. Bra, hej. Yes, the background seems to be, it's the green line somewhere in the background noise here, so you need to accept it. Let's see. This granularity and bending factor, you can change it, but we can't see the background, so it's probably not so important. Keep the background in the pattern, don't remove it, because then sometimes high score, when we remove the background, high score refuses negative. Even when we come produce random variation background, it's silly. Search peaks. There is a significance, minimum significance, and I don't know what the 5 means, so let's try to search peaks. Is this reasonable? Yeah, why not, actually? If we put a much bigger value here, say 555, search peaks. Oh. Or 50 then. Then there were much lower amount of peaks. There are probably, this peak is significant, but maybe depending on how this significance factor is chosen, maybe this need to be changed. So to get approximately a set of detected lines that you can believe in. We accept this. We can actually scale it. These are okay. Let's go through. Seems to be okay, no problem. These are also okay. These are also okay. Okay, okay. Oops. There's nothing wrong yet. And I think everything in the pattern is to zoom out. There is a thing we can do. We could, where is it? Fit profile to get slightly better peak positions. And now in high score there is a where is it? Analysis, crystallography, and search unit cell. And in this search unit cell, there are some parameters here. Cell parameter tested, indexing method, DICWOL it says. I think that is because I usually put DICWOL and it learned that I want DICWOL. But we want TREOR, just to compare. Test monoclinic superaxis and such things. Yeah, why not? I'm not sure exactly. Use the X first peaks. Yes, 10 peaks is no problem. But suppose we do this cell search. Then it actually solves the problem. That's good. So if we go to refine, mark one of the solutions and refine cell. Yeah, wasn't it? Yeah. Directly. Strange. Yeah. With the same data. We'll see. Analysis, crystallography, search unit cell.
How do I change?
Uh-huh. One of the solution have one unindexed line, but nearly the same volume. But we those were just results that show existing results. Yeah. No. Yeah, we take that one then. Then we can click OK here. Yeah.
Oh, how is it?
Yeah, it's
Oh. It's like this.
Yeah. Okay.
Like I have three. You wanna explain? You wanna? How long is? Right. Like this. Well, there. Yeah. I don't know. So I get six.
yeah. They have them.
But then they have different numbers of. It's for me.
Oh, okay. Oh, yeah. One of the same.
Me, David,
Okay.
I think. No, I think you. I think it is. The-
Yeah, I got two.
But all the others. And like, it's very good. One was like. 5. They all have. Like, one is 6. One is 5.
There are some varying results. If that is good or bad.
I mean, like,
Refinement?
one refine.
No.
Okay, so we just count one, 2, yes.
Yes, but we can do that. Analysis, crystallography, and refine unit cell. Now we have, I think I chose 2 different similar. Which one should we choose? We can take the first one. Yeah, and then if we click on calculated and observed peaks, we don't get anything. Maybe we should redo this search unit cell, execute cell, and then we select this one 555 90 90 90. Okay, we can go directly to refine cell, by the way. Nothing shown. I don't like this. What? No, here it's.
Oh, do you have maybe to click on start refine?
Then it comes up. And what we can see here is the deviation, graphically deviation from between the observed and calculated peak, which is 0.06 up to 0.05, 0.06. It's not. There is a systematic tendency, which is a clear indication that we have some kind of systematic errors. And I interpret this as the height error because the silver chloride was deposited on the filter paper. Here we see that 100 is absent. We don't have any observed. And 110, but 111 is present. And 200 is present. We have an observed line for that. 210 is not present. And what is common among these present and non-present lines? If we try to. The 111, 200, 220, 311, 222, 400, 311, 420. All of them fulfills the requirement that either even or odd indices. And this is an indication of F centering in that it's F lattice. Perhaps we should, maybe one can take that into account. In theory, it is not possible, but now we are on into cell refinement, so we can have a look at that also later with another program, but we can stick to high score for the moment. Going to cell refinement and Bravais type. If there is a small down arrow here, I think one can choose all face centered. And then start refinement again. And then we don't have any, not so many lines that are not observed. There is a line here, free, seems to be absent. There are no observed lines, but I mean, it could be weak. If it is present, it should be present at 92.30. On the other hand, we have 511 there at exactly the same position. So that is probably the reason why it's marked as absent here. We can't distinguish two peaks that come at exactly the same line position. Still, it doesn't make any difference except with adding the F-centering with the systematic errors. They are still there, and the information in the table gives, I think, exactly the same result. So can do more refinement. Nothing happens. That's in a way good. So clicking OK. What was the unit cell? It was 5.5502 with a standard deviation of 3. The 3 is probably an indication of the precision. If you look up, I don't know, if you repeat this with a carefully prepared specimen, maybe we would get another unit cell edge and with a similarly small standard deviation. But systematic errors, they will shift the accuracy precision only. Very, very good data in the sense that they give a very well-defined tendency of the difference between OBS and calc. Note, by the way, here it says delta 2 theta. What does delta mean? Is it OBS minus calc or calc minus OBS? It's not obvious. We can have a look. 111 is 27.81 as a calculated value. And here it's 27.87 as observed. So the negative value here means OBS minus calc. That should be positive. It's calc minus OBS, yes. Some programs, for example, foolproof Rietveld refinement program, they use OBS minus calc. So you could run into difficulties just because of that. Well, ideally, the variation of OBS and calc should be small and maybe random. It is a bit random because it's not a perfect line, but if you extract the value, make a picture of it, it's very. There are some technical things, but it's not the traditional thing, right? I think if you have from you have a cubic 5.9 tetragonal.
Because I can't see what go.
Yeah. Yeah. Not with two unindexed. That is not. But I would choose the tetragonal as no zero unindexed. Then I would do refinement, and then I would notice this is serious systematic errors. The term means quite a lot. And then, of course, there should be a warning sign. Cubic or tetragonal? It's an open question, maybe. There are actually, to be honest, several cubic structures that are in practice tetragonal because in cubic sense. And whether silver chloride is that or not, I think one usually claims silver chloride to be cubic. This phase that forms by precipitation.
Can you, that it's like where, even verify.
Yes. So I'm not sure. I don't use the high score for other things than sloppy first test. And if it works, then I'm satisfied. But then I go to programs that are more easy to control and more cumbersome to control also because you need to put in energy. Usually, I mean, the unit cell should be more or less for sure when we can check reduce unit cell. This is here is now we have the cubic. If you transform to reduced cell, where did it go? Analysis, crystallography. It doesn't do anything. But if you have a tetragonal, and does it do any change? Perhaps one could actually enter a new value here. Copy. No, that was not possible. Select candidate. Copy clear table. It's not so easy to do detailed changes in the parameters. I think they mean that they hope for a high score to be a very nice automatic program that solves all problems. But yeah, that's in very many cases. On the other hand, I mean, this is version, I don't know, 3 point something. So we are maybe at a much more advanced level. If they didn't add a lot of possibilities only with millions of tick boxes. But I'm not sure, I don't know how the new modern high score. With the new Bruker diffractometer we got another system, why it's called EVA or something like that, which has slightly very good reputation. But, well, it's another system. I don't use that either. So at least yes, it looks the same. Mhm. Kurs. Yeah, do we have? Well, you have another silver oxide. I can just show them. This is not done here at with our modern machines, but we only have an XY file, or in order to be able to read it into HiScore, we need to change the extension from .xy to .asc, or ASC for ASCII text file. It's exactly the same file. It's only the name that differs. But HiScore refuses to read the .xy. That's strange behavior of maybe HiScore. But we have a Treor file also. I can. This is a file that contains the extracted 2 theta values. So this is silver oxide. Here I actually have a neutron pattern also. Exercises. But this neutron pattern, it is from rather long time ago. So it's not from a very high resolution machine. Can I have a look at it? Did we have new X? So let us see if we can index this file. If we look at the file agox.3, we will see considerably larger number of basing data. I was fiddling around yesterday with this and came to the conclusion that perhaps we need to edit some D1 and D2 limits also. And I did put in -1000 as a volume limit, meaning that it will check for all possible what we call the symmetries, and use the same 390 and AGOX, since we have AGOX.3 as in5, and it actually produced this nice, interesting result printout, but in a monoclinic unit cell test. So let's see if we can go to the bottom and then The figure merit was 85. The Wolf figure merit and the Schmiff and Schneider was 101. 45 observed theoretical lines up to and including the 20th observed. Kind of okay. Since there are more lines available, we also calculate the figure merits for 30 lines or 52 lines. Ideally, these figure merits, the Wolf as well as the Schmiff and Schneider, they should be more or less independent of how many lines are included, because the more lines they come to each other, and the difference between OBS and Calc will decrease. So summing more lines, but with a smaller difference, would sort of one effect would take out another effect. And this is, I think, kind of convincing. It's a small unit cell, 199 cubic angstrom. This you can actually solve just with this pattern. You need the intensities also. We don't have the intensities in the file, but with a small unit, with 200 cubic angstrom, it's something like 10 atoms in the unit cell. And if it's monoclinic, then we need to find the space group. But that could be things for tomorrow and Monday. It could actually, it was actually solved just by looking at these reflections and then converting them to a single crystal data set. Then it's fairly straightforward to find the atoms. I can show the two different data sets. We have the X-ray data set, that is this one, and we have the neutron data set. Sorry, that is this one. They should be the same size, but it's a factor of 10 approximately, because the X-ray data set is quite narrow spacing in between the measurement points, and in the neutron it's much smaller amount of data. But we'll see. I see if I can use Octave. Any one of you Octave or MATLAB? Yeah. So then we'll see X, E, and then I have a script called readxe that reads XE files. You can have that. I can put it up if you want. 4,000 points. So this is a typical X-ray diffraction pattern, quite narrow line, and well, yeah, narrow lines. That is perhaps a large amount of scattering in the beginning and less amount afterwards at higher angles. Just following the atomic form factor, it decreases to higher angles. This goes to 90 degrees, I think. Perhaps one should collect data slightly more nowadays, if you would. It costs some money to spend time at the diffractometer, but Unless you pay for the time, then it's no reason to. Collect as much data as you can. And that is my advice. And the neutron data then, how does that look like? See if I can read it, if finds. Then this is another type of file, so we'll see if we can. Yeah, it worked. 1599, and well, it's approximately the same tendency, a lot of information in the beginning and then less and less. But you see, this was our powder diffractometer at the Studsvik reactor south of Stockholm. It was closed for 15 years ago or something like that. So the peaks are very broad in the end here. So it's not so very nice to solve a diffraction or solve a structure from neutron diffraction or from this type of neutron. If you go to HRPD in ICES, then you would have something better than an X-ray diffractometer and more easily integrated individual peaks, and then you can probably solve it. On the other hand, neutrons are strange particles because they treat the carbon atom and a hydrogen atom on equal grounds. So, and a uranium is also approximately as a carbon atom, depending on which uranium. Some atoms are invisible with neutrons. That is not the case with X-rays. I mean, it's easy to find an X-ray pattern. You can take one at home and then you go to a neutron source and take a pattern, especially if you work with hydrogen. I mean, hydrogen and neutrons, they are friends, so to say. At least deuterium. And then you use both data sets. They should describe the same structure. So heavy atoms like metals and such things is perhaps easier to model with X-rays, and then it's easier to get a good refinement with neutrons. And if you have cadmium, for example, or hafnium, don't bother with neutrons because they are beam stops. Gadolinium also. We were investigating zirconium compounds for many years ago, and we didn't got any information, and we complained to the instrument scientist in Studsvik, and you haven't adjusted your instrument, and he was kind of angry. But then we realized that zirconium and hafnium, they are on top of each other in the periodic table, and looking in the microscope here, realized that we had 3% hafnium. So unfortunately, nothing penetrated the sample. It says only zirconium on the bottom when we bought it, but it's a natural occurrence of approximately 3% hafnium. Often. Mm-hmm.
Right.
Like, yeah.
No, I think that is most. Yeah, I mean, sometimes with the hydrogen, you expect you can have a contamination of normal hydrogen if you come with a deuterated sample. Then don't expect it. You are surprised if it's without any contamination. Even if it says on the bottle 99.99%, I expect a couple of percent contamination. You forget to put on the lid on the bottle. But this hafnium was really difficult, surprising and difficult to discover. But of course, obvious when we realized. You can also make mixtures with neutrons of different elements, that one has a negative scattering length and one has a positive, then they disappear. Yeah, if they are randomly occupied. You can mix heavy water and light water to only get the oxygen visible. Strange, but it will still be an higher background due to absorption, but no scattering, no elastic scattering. But it's useful also. I mean, you can build things. Otherwise, with neutrons, it's only, what is it, vanadium that is more or less silent. So, but nickel and what is it? Titanium, zirconium, I think. Titanium, yeah, a mixture that is much more tough, maybe, and cheaper. Tired? Finally, where is the data here? Manganese oxide. This is the classical compound since the 50s or something like that. This, unfortunately, the raw data comes in the form of a PDF file from a scan of some data. So one just has to type this thing into and realize what it is below the peak here. That has been done. It was actually possible to do it automatically. 95%. There are different versions of manganese oxide depending on temperature. It's magnetic ordering at low temperature. This is the 80K data. Can see if we can. No, this is with magnetic ordering, I think. We'll see. So here is the data. It's, I mean, I know how well it. Probably the data comes at 0.08 degrees of phasing in, but probably just one peak here. But at higher angles, the peak, there was something like 112, 102 degrees or something. Very, very broad. On the other hand, if you have a structure, doesn't really matter. Refinement works well on broad peaks, wide peaks. Structure solution, you can't distinguish, is this one peak or several peaks? That is impossible to. It seems to be asymmetry. But I think it is only one peak. But perhaps not. This is difficult to. This is probably some incremental stuff. a cut here. But with we can look up the peak positions approximately and put them into a Trezor file. So Trezor 90 MNO 80K Fortran runtime error. Then we need to have a look at the data. Comma tecken, volume. Is really true. Optimize at line 2000. Bad value during. I don't believe this. Make it. What did we do wrong? Why do Trezor have such a problem? Exactly. I'm not sure exactly, but I think it's 1.25 or something like that. Fine. Speed. Alt F. Right? It worked yesterday. Right. Yeah. No, no. And there are no commas, there are only dots. Comma. And I don't have the end star is not the, there are blank lines below. Choice is correctly spelled. No, I'm sorry, I can't explain.
And then on the
Preferably not. And this is also strange. Too few lines for monoclinic test. We didn't. Perhaps we should avoid the. That we can do. Take away the negative volume indicates test all symmetries. Otherwise, it will. But exist. I mean, it shouldn't be like. There is an error there. No. I can't see if I can find a solution until tomorrow. Because it's I don't see a problem with the data actually. Wave that wavelength. Otherwise, it would assume copper wavelength, but
Made add that's label 1.002. The first error. Fire.
I haven't written it.
oh, volume and 1000. Value increase, for example, not change full value. So or
Could be, but yeah, we can give it a try. But we don't have a volume now. I deleted it.
Oh.
Let's see if we can. I can't use this notepad very fluently, so I use another editor instead. We'll see. Here is yet another program that I use for conversions and refinements and such things. It doesn't, no spacing data give, sorry. But these are the spacing data, yes. So now we should export. We can MNO atk.lou. Now we have a file with input file for DICWAL. I'll show you how it looks like. So a typical DICWAL file is something like this. It also contains all the spacing data. 68, wasn't it one before? First, some text, and then number of data files and data lines. Type of data, 2 means 2 theta in this program. This one means test cubic system, test tetragonal, hexagonal, orthorhombic. Do not test monoclinic or triclinic. These take a long time, so that is the why we don't put a 1 there. And then there are some limiting values of unit cell edges, volume, minimum volume and maximum volume, minimum and maximum monoclinic angles, or also triclinic angles. If you would like to test higher angles, you need to change it, for example. Here is an estimate of the error. Maybe this could be increased actually to 0.1 degree or something like that. A minimum value of what's it called, the figure merit, and some indicators for whether one should refine point error or not. So let's see if DeQual will solve this problem. I think we have DeQual 06 available. Yes, it is obviously from the what's it called, Grenoble, the foolproof suite of programs. Does it say LLB, Cyan, Ressa, Clay, or something like that? Enter the name of the input file. MNO atk.lou. Start to hate this. 8 lines, 9 lines, 11, I mean. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Other section.
Why did they disappear? Maybe my computer is somehow strange. Protests. So, LOU. Just check. Why did it start this? Programs. This is not the Grenoble version. Copy this one to my bin directory, users, Derek. So let me try again. DeQual 06, never give up. MNO, ATK, LOU, yes. Ut, 1. This is Swedish for out. And it works. But it didn't solve the problem. Ut. A French program. From University of Rennes. Yeah, it did. Cubic system 4.43. Or at least that is a unit cell at least. Free. So this is all odd, all even, all even, all odd, all even, odd. Maybe this is the room temperature data and not the ATK data, because the ATK data should be twice the unit cell. But this is at least reasonable, and there's no reason not to believe these data. Here we got a figure merit of 435. Very high. there are 51 calculated lines up to 13 observed. That is strange. But since we have either all even or all odd, that means that we have F-centered lattice, and we should divide the number of theoretical reflections by approximately 4. So then suddenly 51 divided by 4 is approximately 13. Obviously, all reflections were visible. So how do we solve a structure with a unit cell edge as small as 4.43? For those of you that come from the single crystal course, the direct methods are useless. No phasing information, but Patterson maybe. Or just sit down and think, in how many ways can you arrange atoms? You know that atoms are approximately 2 angstrom from each other. They are in the size of 1.5 to 3 angstroms size. If this is F-centered, we should have 4 atoms in the unit cell. 4 times there is only, if this is manganese oxide, there is only oxide ions that can take place, and then the manganese Mn2 plus, they are probably quite small, so it's a sodium chloride structure. At least I would like to believe it. We can try to refine it later. Here we saw that the tetragonal system 3.13 and 4.42. How does that compare to 4.43 only? Yeah, nothing wrong, but the 3.13 is related to half the diagonal of the 4.43 cells. Dickwell do not take care of. Here is yet another version with a shorter z-axis also. But one of the lines were marked with stars here and seems not to be present. Otherwise, no problem. The good thing with Dickwell is that you can indicate this extra error. Suppose we would have thought that it should be very, very accurate, these stuff. Does it work? Mm-hmm. It still found it. There's probably some kind of implicit error limit also. Did it? The search of a 0-point shift is unsuccessful. Where is the? I didn't believe my claim to be extremely accurate data. The outcome from having, I can't explain the problems with Treor, but you should have several different programs at hand. One may not work, but the other one do. Ideally, several programs should give the same answers. Then you could be quite confident that there is not only random errors in the code. So DeepQual, Treor, well, the HiScore, yes. Ito, that is part of HiScore that we haven't tried yet, but it's mainly useful for low symmetry patterns. And MacMaye and these other type of programs. There are some boxed set of programs. There is a system called Crucifire that may be old now and out of date, but that packs several different programs together and tries each one of them, which is reasonable, but you can also have them available manually. Or, well, like in HiScore, you can select the different programs. Yeah. Maybe I mean there are possibly GSAS is a structure system that has a indexing procedure that I don't understand really how it works. Quite slow, but I think it's related to DeepQual. But it's nothing wrong. Someone wants to write an indexing program that is not bad. But I recommend get yourself a bunch of programs, and then maybe you get used to one, so you only use that one all the time. But when you fail with that one, then try some other program. Expo and Fox has several, at least Expo has several programs. At least Treor and DeepQual and maybe more built in. Yeah. Since it doesn't matter, the origin of the data doesn't matter. It's only the geometrical size of the unit cell. And then
Automatically.
Yeah, that you need to, if you do have constant wave neutron data, then you need to put in the wavelength. But with the what's it called, time of flight data, then D values, because they you can convert time of flight to D values or Q values that are independent, only related to the geometry, is perhaps to try to stay away from 2 theta. And I mean, for X-rays, you really get 2 theta, but convert them to D values. Or, I mean, D values are more general than other stuff. Then it's a problem, of course, to find the D values, the 2 theta values. In the time of flight spectra, you have strange type of profile functions. But I mean, you can also just visually localize the maximum intensity. Then it's first when it comes to Rietveld fitting and something, then you need to have some good estimate of profile function. We should talk about profile function. I need to dig in more. Yes. Yeah.
Yeah. So, I mean, how do you?
Yes. Yeah. Yeah. In high score, you will find, we can have a look at that. If this is the, yeah, here is the fitted position to theta. What is this? 5. Anchor, peak list. Here is the to theta. And if we do a fit profile, yeah, they should come out with the estimated standard deviation of value 3 here and a width of the reflection. If you want to store these if you don't want to use them in high score, but in some external, I recommend file and save as. What should we save? There is a long list of possibilities. High score files and document templates and different types of. What do we like? We like text files and such things that we can understand what it is. For example, JCamp ASCII peaks. But yeah, the Shellex files is perhaps not of interest because we haven't any information on those. JCamp ASCII peaks, that is, if we then agcl.gdx is saved, we will see what it will contain. agcl.edx. Where did it come? agcl. Didn't I save it? Aha. I need to answer. Okay. Then we'll see. One more try. agcl. Here it is. And then opening this. Perhaps you don't believe me that this was a simple file too. But I mean, it's a lot of crap here. Yes, information. But here in the end, the other hand, you have. Sorry, where am I? You have angle, width of the peak and height, for example. So, and if you have the width and the height, you can estimate the area. And I think you could also. Why didn't we got the area? I think we can get the area. We can area calculated. Why didn't it calculate the area? Refine all peak areas. No. Now here is the area. It was the counts that times 2 theta. But do we get it? And we save. All no, it seems we only get the height in this, but at least the 2 theta values we can get. And if you have few values, I mean, then maybe copy them. Otherwise, what do I have to say? If you're among the programs in the box, if you look, there is a directory Puder, where there is this is essentially a refinement program just for unit cell and for exporting data to different other type of programs. It's not at all automatic, definitely not. And it's a laboratory essentially for me, but I mean, could be useful. And in the manual, there are much of the material that I showed today is in this manual. So where are we? Nej. You read some kind of data with if you have a PUD file. I have a sync, an erroneous sync with a huge height error. And do we know the unit cell should be 2.66 and 4.95, 67 and 95 for metallic zinc. So we get a diffraction pattern. It looks quite okay. A lot of peak positions and quite not very thin peaks, but quite thin. So if we index this and write out the data, nothing except number 17 is indexed, which is very strange. Wasn't this synced? We can set the delta to theta acceptable to a higher value, 0.1 degree maybe, because it may be of low accuracy. With 0.1, a few more peaks are indexed, but hardly anything to count on. If we set delta to theta to 1 degree, horrendously large, and index and write the data, we see patterns. Then we, except this one, we get everything indexed with the delta to theta of minus nearly a degree in the beginning, and then decreasing less and less up, going positive here, but I don't trust these values. But at high angles, the closer to 180 degrees into theta, the smaller 0 point height error means. But at low angles, it means a lot. So this is far away from what one should accept. And unless you know that this error has occurred, then it's impossible to interpret the pattern, or at least to index it. If you start to refine it, then we can do it 2 times maybe. Then it actually partly this maybe spreads out strange differences. But the unit cell parameters stay approximately in the vicinity 2.67, and this is not at all reliable, I would say, because we don't know what effect these systematic errors has. Now they are both negative and positive, so perhaps they cancel each other. With 0.3, still we get approximately very stable. So you need to identify what's problems. I mean, you have problems with various things: computers, command line terminal, editors, Treor. I dare not to say that anyone has problem with DQual, but and if you want to create an input file with DQual, then perhaps one should go to programs and this DQual06.txt, which is also a comment list from Fortran, but it's only 6 pages long. So for each, now let's see, for card 1 should be the title. Card comes from punched cards. Back in the Stone Age, we had punched cards. I just started here when we got rid of the punched card. But record number 1 or line number 1. And line number 2 is these parameters, and they are described below here. 3, 4, 5, and number 6 to 6 plus n total is the actual the spacing data. It says here D, doesn't mean D value, but it's just spacing data. Why not D? And then there are some suggestions how you should work. Some references, only to the authors, but there are a lot of, you can search for Google for indexing on Google Scholar, and it will get 100 papers. There's still some articles written within the field of indexing. Not many. And if you read French, then I recommend these early Loire and Loire articles. Yeah, very well written. You do. Do you encounter Dicol in French literature or chemistry studies? Or maybe. No. No, but I mean, in solid state, I think those people are big in France, at least. Here in the articles, I saved a couple of these, each 10 years, 70, 80, and 90 in 2004. There are more of them, but also in references here, there are a lot of different. Have you been looking at the Dinibi and that and Billy and Pecharsky? They are quite dry. If I should be kind. But you can have a look through them at least. Search for it. It's a lot of material. No. This is, I mean, the Billinger book is general, partly general crystallography, but also powder diffraction, if it loads. Yeah, we can do something else in the meantime. No, we can't. I don't know. It seems to be slow. Is it big? Maybe. $20 meg. That is not so big. Yeah. But now what? Hacker attack on SU, maybe. Theory in practice, I think you can. It's quite good, yes. Yeah. But it's a lot of text. And I mean, it's quite complete principles and experimental setups and such things.
But I feel like, phase introduction.
Yeah. Yeah.
I haven't got.
But I mean, if you go to this bit inside, now let's see. Yeah, here is indexing and space group determination. This is this table, yes. And those similar to what we have. Everything is there. Historical indexing program. There is mentioned Ito, Trior, and Dicol. Ito is actually sometimes unknown program because it's very well suited to low symmetry patterns, especially triclinic and monoclinic, but maybe not to high symmetry. But there are modern versions of that also available. Modern, less than 30 years. And Trior is a new version, or I don't know if it is evolved, but that is part of some Expo, for example. And Dicol 04 and Dicol 06 is also, I think 06 is the last one. There will probably be a new student in Rennes and someone interesting to increase. Excel, I don't have experience with that, but within commercial software setups, they are probably very good. And I suppose they are well programmed with modern methods to avoid errors and such things. But yeah, you don't need to buy them. I don't think so. Space group in determination is perhaps difficult, I would say. Yeah, we have a look at that when we run next. No, Monday, maybe. Monday. We do tomorrow. We look at profiles and how to get intensity data and solve some structures. We can solve a cubic structure, 2 cubic structures, and 1 monoclinic, maybe, with traditional lookalike single crystal methods, and then comparing with powders. In practice, perhaps you don't do that unless you have a high symmetry pattern and Expo and all automatic programs fail. Then it could be worthwhile to go back to the basics. Especially with cubes, because then you have good access to individual intensity. And Shell XD and Shell XT, and they are still in region of their own. Yeah, should we? Yeah, tack. Is this one? I will have an enormous file here. I stop this recording now. If anyone is left.